Welcome to another rendition of Math is Easy, step by step. So this video may be a little bit shorter than some of the other videos. I'd like to go over some more exponential examples of multiplying with exponents. So we're going over those rules. As you can see here in problem number one. And if you haven't seen some of my videos prior, I talk about invisible ones. Show those invisible ones. All right, where we have numbers, sometimes if you show that's a 1y, it'll help. Oh, that is an exponent to the first power. I go dot, 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 just to kind of show you, hey, that's an invisible one. Because a lot of times they don't show you. They just say that's a 5y term. Or, hey, that's y, right, all by itself. So if you missed those videos, please review those. They might help you understand things a little more clearly, because when you show these invisible ones, it takes away the confusion of what am I going to do with that 3y and the y. I just don't get it. So go ahead, review, take the time. It'll help clarify a lot of things. I think it helped me when I used to struggle with math. So we have a problem here, 5y times 3y times y. And if you remember from previous videos, when you multiply with exponents, you add, the rule is you add the exponents, right? And so showing these invisible ones, there's an invisible one in front of the y, and then there's an invisible one in each of these exponential placeholders. Show them, right? I show a dot, dot, dot to indicate, hey, it's an invisible one. But you can go ahead and write a 1 there. Show these invisible ones. Right here, you can go ahead and draw in a 1y right there. So it'll clarify things for you. So moving forward, in review, when you multiply and you have exponents, they do not have to have the same base. They do not have to have the same like terms, like when you add and subtract. Here, you're just going to multiply the coefficients. Those are the numbers in front of the letters here, y. So 5 times 3 is 15. 15 times 1 is 15. Hey, I'm going to write a 15 in here. Now each of these terms is attached to y through multiplication. This means multiplication. 5 times y, 3 times y, 1 times y. So I have to include y in my answer. And again, when you multiply, you add the exponents. These were all invisible ones. So show these invisible ones. 1 plus 1 plus 1 is y to the third power. So again, 5 times 3 times 1 is 15. You keep that variable y attached to the 15 through multiplication. You add the exponents. 1 plus 1 plus 1 is 3. The answer here is 15y cubed. All right, let's take a look at another example. And hey, if I'm going too fast, please stop, rewind. You can go at your own pace when you're watching these videos. So let's take a look here at problem number 2. Now, for some people, because adding and subtracting, I talk about if the base is the same, you want to keep the base the same. And here, I am keeping the base the same. You can, it makes it a little more difficult because we're just talking about exponents right now. But you can say, hey, this is 9 squared. That's 9 times 9. Times 9 squared, which is 9 times 9. So 9 times 9 times 9 times 9 would give you a simplified value, right? Or if you keep the base the same, 9 times 9 is 9. And then we add the exponents, because when we multiply with exponents, 2 plus 2 plus 2 is 4. Again, 9 times 9 times 9 times 9. What you don't want to do is multiply 9 times 9, which is 81, add these exponents, 81 to the fourth power. That's going to get you a wrong answer. So to keep this simple, it has to do with the order of operations, basically. So by keeping the base the same, you add the exponents here, and later you can simplify 9 times 9 times 9 times 9. To me, that's the simplest way. You can break this down into 9 times 9 times 9 times 9 if you like. Both of these methods would give you the same answer. But since we're talking about multiplying rules with exponents, you want to keep the base the same. 2 plus 2 is 4. All right, hopefully I didn't lose anybody there and confuse you. I apologize if I did. So here we got a little more. We got a few more terms added to the mix. We got 2x to the third power y to the second power times 2 times x to the third power y to the second power. And you, again, this base is the same as this base, right? And we want to show our invisible one. So this is 2 to the first power. So I'm showing a dot, 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 dot. This is 2 to the first power. I'm showing a dot, 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 dot. So my answer, I'm just going to keep 2xy the same. The bases are the same. You want to keep that base the same. Then we just add the exponents. With this 2 to the first power, 2 to the first power, 1 times, 1 plus 1 is 2. X to the third power, x to the third power, 3 plus 3 is 6. Y to the second power, y to the second power, 2 plus 2 is 4. Another way you could look at this, if I got a little bit of room, I can break it down simply like this. This is 2 to the first power times x to the third power times y to the second power times 2 to the first power times x to the third power times y to the second power. And remember, there's invisible ones in front of these variables that don't have a coefficient or number. So again, 2 times 1 is 2x, 2 times 1 is 2xy, and that's what gives you the term up here above. So hopefully that gave you a little bit further of an explanation. Again, hopefully I didn't confuse anybody with that further explanation. Let's take a look at number 4. And we're going to get into a rule here that I have not covered, so I'm simply just going to tell you. Anything to the 0 exponential power is 1. Anything to the 0 exponential power is 1. But we're not covering that today. We're going over the exponential rules when you multiply. So we have y to the 0 power, z to the invisible 1, right? I want you to show these invisible 1. That's z to the first power times a to the second power times y to the second power times z to the second power times a to the invisible 1, right? That's a to the first power. Even though they don't show it, and many times in your problems it'll be left alone. Hey, show that invisible 1. You can go dot, 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 or you can just write a 1 to help clarify what you need to do. So remember, when we multiply, we add the exponents. We add the exponents. So here I'm trying to show you a little bit further, breaking it down. This is y to the 0 is 1 times 1y to the second power times 1z times 1z to the second power. Remember, that's z to the first power. You can just write that in here. Times 1a to the second power right here. Times a to the first power, which again is just an invisible 1, an invisible 1. And if you want to really break this down, what's 1 times 1 times 1 times 1 times 1 times 1? It's 1. Y to the second power, that's it. There's nothing to add. It's y to the second power. These are all attached through multiplication, which is why you see it here. Z to the first power times z to the second power, 1 plus 2 is z to the third power. And a to the second power times a to the first power is a to the third power. So hopefully this helped you out. Hey, math is easy step by